Okay, so today we're going to look at our similarity rules. This one seems fairly straightforward, and we're going to give a fairly straightforward proof for it as well. It says if an angle of one triangle is congruent to the angle of a second triangle, as you can see in the example below, and the length of the sides that includes those angles are proportional, then these triangles are similar. So that's what we've got here. 15 over 5 is equal to 21 over 7. And so what we're saying is if this was length x, we'd have to say that this length over here was 3x. This can be easily proven then using our proportionality theorems. Okay, here's another triangle then, ABC, and what we're going to do is we're going to extend AC and AB. There we go. Extend and use an array. And now what we're going to do is draw 2 points, or add 2 additional points. Let's call that D, and let's call that E. And we've added them so that AB over AD is equal to AC over AE. So what we're saying is that these line segments are proportional to each other. Now what we found out then from our proportionality theorems is if this is the case, if AB over AD is equal to AC over AE, then the line joining DE must be parallel to BC. Okay? And if that's parallel to BC, then that means again we've got equal angles here. And if we've got sides we've got triangles with congruent angles and proportional sides, then that means that we've got 2 similar triangles. ABC triangle must be similar to ADE. Let's take a look at an example then, or a question. It says in the figure, it says, you can read that yourselves, gives all the lengths and the equal angles in the diagram. It says find BC. BC we'll call X then. Okay, so I think it should be fairly obvious. We're looking to show that 2 triangles are similar using the fact that they've got 1 congruent angle and 2 proportional sides which contain that angle. We can see then that, yeah, the 2 angles are congruent. There we go. Very nice. And all we need to find out is if the sides BD and its corresponding side BA, if that is the same as DE divided by AC. If we can show that, then we must have proportional side lengths, and then we must have congruent triangles. So let's just check that out. Use a slightly different colour. BD is 5 all over BA, which is going to be 15. DE, where's the E gone, is 4 all over AC, which is 12. And what do we end up with? Yep, 1 over 3 is equal to 1 over 3. So this means that we can say with confidence that BDE triangle is similar to BAC. With that in mind then, if we go back to the diagram, we can see that the scale factor, what we've enlarged the triangle by, is what? If BD is 5 and its corresponding side is 15, then obviously we're multiplying by a scale factor of 3. And then we say, well, okay, if I want to find BC, the corresponding side to BC must be BE. So very simply, BC must be 3 times 6. which is 80. And there we go.